Hello everyone, good morning. Dear authors and invited guests, welcome to technical session 2D. Myself Tanish Virmani and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to invite you for the International Conference on Technological Intelligence and Business Strategies TIBS 2026, Manila, Philippines. This conference is being organized in a hybrid mode. The physical event was held yesterday in Manila, Philippines, and the virtual event is being held through Zoom from 23 to 24 June 2026. I hope we will all enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have total 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answer. After 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, then you can write to us in the chat box. Just before we start the session, I would like to introduce the session chair. The session chair we have for this session is Dr. Kalpesh Popat, who is an associate professor at Marwadi University, Rajkot, Gujarat, with over 20 years of teaching experience. He has published more than 30 research papers in international conferences and journals. His research interests include mobile computing, Internet of Things, AI/ML, and cybersecurity. Now, I would like to start with the papers. Also, sir, if we can have some words of talk with you. So later we can have the talk. I would like to call the first author, Raj Kiran Nair, for the paper title Advancing Women's Financial Inclusion Through Digital Investment Platform. Do we have Raj Kiran, sir? We'll go with the next presenter. Next author we have Shravani Patil for the paper title AgriMitra, Empowering Rural Indian Farmers Through Blockchain and AI-Driven Market Intelligence. Do we have you, ma'am?
Yes, sir. Yes, I'm
Yes.
present.
You can start your screen.
Yeah, just a moment.
Yeah. Ma'am, you can start your screen sharing.
Just a moment. So actually, the Canva link is not loading. That's why I'm taking a moment. I'm very sorry.
If it's taking time, then we can move to the next author. Then once the next finishes, you can come next if it's fine with you.
So I'm ready.
Okay, sure. You can start your screen.
Is my screen visible?
Yes, ma'am, it's visible.
Okay. So a very good morning, everyone. My name is Shravani Anil Patil from Vivekanand Education Society's Institute of Technology, Chembur, Mumbai, Maharashtra, India. And today I'm going to present our paper on the behalf of my co-authors and myself, that is AgriMitra Empowering Rural Indian Farmers Through Blockchain and AI-Driven Market Intelligence. The reality of Indian agriculture. Imagine a farmer selling tomatoes at rupees 10 per kg and a consumer buying at rupees 40 per kg. Where does the value in this entire chain go? This goes to middlemen, lack of transparency, delayed payments, and information asymmetry, which is understood by the fragmented agricultural supply chain, which results in the misery of farmers. Unfortunately, in our country, farmers often receive only 20 to 35% of the final market value. Why existing systems are not enough? Traditional mandis, Enam, Kisan Sabha, or Go Fresh like private platforms have price manipulation, delayed payments, limited adoption, no predictive pricing, lack of blockchain transparency, commission based, partial farmer to customer trade, and that's where our solution AgriMitra comes into picture. AgriMitra is a one-stop platform which integrates functionalities like blockchain transparency, direct marketplace access, logistics supports, and AI-driven market intelligence for the farmers, which makes it not just a platform but an entire ecosystem to improvise the lives and also the financial hopes of our farmers in the country. Our innovation. Firstly, it's the blockchain transparency, which ensures that records are immutable via smart contracts and authorized access. AI price recommendation, direct farmer buyer marketplace, market intelligence, community logistics, and secure transactions. Proposed design. So our project that we have implemented has basically three portals. That is the buyer portal, farmer portal, and the driver portal. So the buyer portal are the end users who order products and directly access the functionality. Farmers are the ones who come here for selling their produce. And the driver portals are the logistics operators who support the transport of goods between the farmers and the buyers. Additionally, and most importantly, our project has three main important layers, that is the blockchain layer, AI layer, and the logistics layer. The blockchain layer stores records using smart contracts in an immutable way. The AI layer helps farmers with intelligent price recommendation, and the logistics portal includes the logistics operators, which improvises the transport of goods and services between the farmers and the buyers. The literature survey that we have done explains that there have been a few platforms which integrate and have deployed projects using blockchain technology, whereas the other findings tell us that other projects have been made primarily on the grounds of AI and ML. However, we found that there has been a gap where there is no integration between blockchain and artificial intelligence. So that's what encouraged us to go and develop a platform like Agrimitra. Now, the tech stack of our system is, so for the software requirements, the development tools have been database, we have used MongoDB, front end using React, backend is Node.js, IDE is Visual Studio Code, ERD we have designed using Canva, and the hardware requirements, minimal configuration processor, Intel i3 or Ryzen 3 or higher, RAM 4 GB or 8 GB recommended, monitor 15 GB color monitor. Now, how does a smart blockchain layer exactly work in our project? Basically, there are two contracts in a project. First one is for the ad project, and second is the buy request. Now, whenever a farmer adds a product, the smart contract stores the details of the products on the blockchain, which ensures that the crop data is immutable, especially the price and the quality. Once a farmer has entered the data, it could not be changed or tampered in any way. And the second smart contract is for the buyer request. Whenever an end user requests for a produce, that request is registered via transaction in the blockchain, which ensures that again this transparency and tamper proof process. So add product, buy request, and then eventually it goes to the blockchain. Now, performance metric. Now, our platform has demonstrated the following performance. Firstly, it has 71% of faster turnaround, meaning that the produce reaches to consumers in a much lesser time in comparison to the traditional mandi model that is deployed most of the country. So the reason behind this is there is a very less scope of the intermediaries between the whole transaction that happens between farmers to the consumers. As a result of which, the produce reaches to the door of the consumer in a much faster way. The second is 93% of delay reduction. The middleman payment delay, which is generally 70 to 30 days, Agrimitra has brought it down to 24 to 48 hours. 72% of fee reduction, that is associated intermediary cost, which is basically commissions and other delayed payments and lots of intermediaries involved between the ecosystem. 90% faster approval, that is document and verification, as there are lesser parties involved in the transactions. Again, the documentation and verification is lesser. And fully immutable logs. Blockchain ensures that there is a market price transparency between the farmers and the buyers, and there is no third party or an unauthorized person or a group of individuals who are tampering the data. Now, the ML based price prediction model has the following details. The data processing, we use 22,965 agricultural commodity records. The features are nitrogen, phosphorus, potassium, temperature, humidity, the pH of the soil, rainfall, crop, and the state. Missing value handling, encoding, and scaling. The model that we use, firstly, our linear regression was a baseline model. However, random forest outperformed it along with hyperparameter tuning. We have used threefold cross validation. Our data set was split in the train to test ratio of 80 is to 20. and the R score, that is coefficient of determination, came out to be 0.939638. The challenges, as in most of the IT projects, the challenges in our project that would be seen when we deploy it nationwide would be infrastructure limitations. That is, as it begins from farmers and in the rural areas of countries, there has been limited access to internet and smartphone availability, farmer digital literacy, need for training and awareness to ensure smooth adoption, scalability concerns, managing costs and performance at a national scale, regulatory challenges, as blockchain as a technology has a lot of legal framework regulation that has to be still done. These could be a major challenge when we deploy this project at a larger scale. Conclusion says that Agrimitra is a smart agricultural platform that tackles key farming challenges by directly linking farmers with consumers, removing intermediaries, and ensuring fair prices. It uses blockchain to provide transparent, tamper-proof records and machine learning to predict prices, demand, and yields accurately. This tech integration boosts farmer income, builds consumer trust, and promotes a sustainable, transparent, and future ready agricultural ecosystem. So, thank you. And that's it from my.
Sir, if you have any questions, or we can move to the next author.
Hello, am I audible?
Yes, sir, you're audible.
Presently, can you tell me why you have used AI in this project? Because you have a major focus on blockchain, and then why you have used AI for?
So AI actually came as an additional feature on our project. When we began with the project, our primary focus was blockchain itself. But as we wanted to make it an entire ecosystem and not just a blockchain-driven platform, we have included AI as well. And in the future, if we plan to expand this project, we will also include other things like a multilingual model, then chatbots, and etc. So AI, of course, has been on the second priority, but because AI can also help farmers for price prediction, then in the future we can also include crop recommendation. That was the major reason we tried to include AI as well. However, primary focus has been on blockchain itself.
Oh, thank you. Can we have the next presentation?
Thank you so much, sir. Thank you for the opportunity.
The next presenter I would like to call is Dipanvita Chakraborty for the paper title Consumer Behavior Towards ICT-Enabled Credit and Discount Mechanisms in the Petrochemical Retail Sector, Implication for Policy Framework. Ma'am, do we have you?
Yes, sir.
You can start your screen sharing.
It is showing that screen cannot be shared, disabled share.
No, you can try again. I've stopped screen sharing.
Is my screen visible?
Yes, ma'am.
Okay, thank you. Good morning, everyone. I'm Dipanvita Chakraborty from Haldia Institute of Technology, West Bengal. Today, I'm presenting our research titled Consumer Behavior Towards ICT-Enabled Credit and Discount Mechanisms in the Petrochemical Retail Sector, Implication for Policy Framework. My co-authors are Dr. Arunangshu Giri and Mr. Manush Ratre. Basically, our study examines how consumers respond to digital credit and discount mechanisms and what factors influence their adoption behavior. So, to start with, the petrochemical retail sector is gradually moving towards digitalization through ICT enabled payment systems, credit platforms, and loyalty based discount mechanisms. While these systems improve efficiency and cash flow management, their success depends on customer acceptance. Therefore, understanding the behavioral factors behind adoption become essential. This study investigates the determinants that encourage customers to shift from traditional payment methods to ICT enabled alternatives. Existing studies mainly focus on operational and financial aspects such as pricing, logistics, and receivables management. However, limited attention has been given to behavioral and relational factors, particularly the roles of trust, peer influence, and customer relationships in encouraging adoption of ICT-enabled payment mechanisms remain underexplored. This gap motivated our present study. The study contributes in three ways. First, it extends the diffusion of innovation theory to the petrochemical retail sector. Second, it explains how socioeconomic and relational factors influence adoption decisions. Third, it provides practical insights for managers seeking to improve digital payment adoption and credit management efficiency. Now, the theoretical foundation of this study is diffusion of innovation theory. According to diffusion of innovation theory, innovations are adopted when they are perceived as useful, beneficial, and easy to try. Communication and social influence reduce uncertainty and facilitate adoption. Therefore, trust, peer influence, and we are just relating the theory with our study, that why we use this theory, because it actually captures that fact that trust, peer influence, travelability, and perceived benefits become important factors, which are our factors, whatever we have used in our study, to influence customer behavior towards ICT-enabled payment systems. Now, these are our key constructs. First one is customer relationship quality. This reflects trust, satisfaction, and commitment. Peer influence captures recommendations and shared experiences. Price orientation reflects customers' focus on economic value. Triability measures the opportunity to test the innovation before adoption. Relative advantage refers to perceived benefits over traditional methods. Finally, customer demand and purchase intention presents willingness to adapt and continue using the system. Now, this is our hypothesized research model based on the diffusion of innovation theory. We propose that customer relationship quality, that is CRQ, peer influence, that is PRI, price orientation, that is PO, they positively influence trialability, that is TRI, and this again influence relative advantage, that is RA. It influences in a positive way, and that will again in turn will have a positive influence on customer demand and purchase intention, that is CDPI. So accordingly, 5 hypotheses we have developed. Now coming to the constructs, these are actually the items that was there in a questionnaire whenever we are collecting the responses. So customer relationship quality scale, all the scale we have adopted from established literature to establish the to ensure the content validity. So all these are established scale that we have used in our questionnaire. So customer relationship quality was measured through basically 3 dimensions. One is the sense of belonging, second is customer satisfaction, and third one is the reliability platform. The next come to peer influence scale. Peer influence was measured through learning from peers, recommendations, discussion, shared experience, and observation of peer behavior. These are the things I have given here the original items also, and how we have used the original items in our study, because it is not possible to exactly use the original items always. So we need to reshape the wording without changing the main theme. So next come to the price orientation scale. Price orientation measures to extent to which customers seek economic benefits. The scale captures customers' tendency to prefer alternatives that reduce expenditure and provide better value for money. The next one is travelability scale. Now, this reflects the ability to test the ICT-enabled system before full adoption. The items uses whether customer received adequate opportunities to experiment with the system and evaluate its benefits. Relative advantage scale, the next one is, this measures the perceived superiority of the new system. The items focus on time saving, efficiency, usefulness compared to traditional payment mechanisms. This is the last one, that is our output of the model, that is customer demand and purchase intention scale. This construct measures future adoption intention. The items assesses the likelihood of purchasing, trying, and repeatedly using the ICT-enabled mechanism. So next come to the methodology. In this study, we have adopted a mixed method approach. Qualitative exploration was conducted initially to understand the context, and that has been followed by quantitative analysis. So it is a in vivo software generated word cloud picture. What in vivo actually does, whenever we will fit the system, the responses that we get, we need to code the statements. We actually want to see that what are the things that has been repeatedly used by the respondents. So bigger will be the font size, bigger will be the intensity of use. So here we can see relative advantage we can see over here. Purchase intention we can see, price orientation we can see, okay, trialability we can see. So from there actually what we are doing, we are relating with the factors that we have taken from different literature, that these are actually being visible. We are relating with the customer responses with the literature, because we need to use the scale to measure customer responses quantitatively. So that's why first we need to ensure that whatever factors we are using for a study, that are actually measuring our final output, that is customer demand and purchase intention scale. So this is the quantitative analysis. We have used SPSS and MOS for all the calculations. Now, the first one is the study has as we are adopted quantitative analysis after uh, adopting a qualitative analysis. So this is actually the respondent profile. Most respondents were agents transacting on credit, that we can see. Credit-based transactions accounted for nearly 3/4 of total transactions. The majority of respondents purchased less than 200 liters, and well, about 1/5 represented bulk buyers. This profile reflects the practical customer base of this field retailing sector. So this is our measurement model. And another thing I will like to tell, that whenever we have collected the data, we used a convenience sampling model and cross-sectional research design that we have used. Now, come to the measurement model. Before hypothesis testing, we need to test the reliability and validity of the study constructs. So here we can see that composite reliability, that is CR, for all the study constructs, the CR value is more than 0.70, which is in the threshold limit, and it indicates the strong internal consistency. Next, we come to the, there are two types of validity. One is convergent, another one is discriminant validity. So, we can see in the measurement model that the AV values of each study construct is greater than 0.50. This confirms convergent validity. Again, the AV value for each study construct is greater than the corresponding MSV and ASV values for all the study constructs. This actually establishes the discriminant validity. Again, we can consider the diagonal values like 0.836, 0.799, 0.807, 0.822, 0.828, and 0.809. These are actually the square root of average variance extracted, or AV. So these are actually we can see these are greater than the interconstruct correlations. Like we can see 0.799 is greater than 0.275. So this week, and this is happening for all the study construct. 0.822 is greater than 0.128, minus 0.162, and minus 0.135, like this. So therefore, discriminant validity is established. Now come to the hypothesis testing, and we had 5 hypotheses. So this is the structural equation modeling through SPSS, whatever we have done, SPSS and MOS. All proposed hypotheses, we can see that it has been, all have been supported. Customer relationship quality, that is C or Q, significantly influencing trialability, that is TRI, and we can see the beta value is highest, that is this is the strongest relationship among the 5 relationships. This is 0.382, the highest beta value we can see over here. Next is peer influence, that is PRI. It will positively affect trialability, TRI. And then one is price orientation, PO. It is also have a positive impact on TRI. Then TRI is influencing, that is trialability is influencing customer, the relative advantage, that also we can see. And relative advantage again gradually can actually influence the customer demand and purchase attention. So we can actually, basically we can see that the customer, first of all, it is important that customer relationship quality, it is very important as it is related with the trust. Once trust is built up, then only the customers will agree to use the system as a tenable system. If they don't have any security issues, then only they will agree to that. Next is peer influence. That
Excuse
is
me,
also
ma'am.
a major thing.
This is just a gentle reminder that 12 minutes of the presentation are up.
Yes, yes. I will wind up quickly. Peer influence, that is also a very significant and essential thing, because what happens, these we have actually done with the dealers, different and transporters. So they have a, they are connected with each other. So if one is giving a very positive feedback, other will get influenced with that. And the next one is price orientation. That is actually customer always want to justify the value that they're spending. So therefore it is also obvious, and they can always can take a chance. These three will actually influence them whether they will like to take a test use for the system or not. And if they feel that it is advantageous, definitely they will go for that. Now, next one is theoretical and managerial implications. Theoretically, the study extends DUI theory to the petrochemical B2B retail environment. It demonstrates that trust, peer influence, and economic value are important antecedents of innovation adoption. Managerially, organizations should strengthen customer relationship, leverage peer testimonials, and clearly communicate economic benefits to increase ICT-enabled payment adoption. To conclude, we can say that relationship quality, peer influence, price orientation significantly affect customer adoption of ICT-enabled payment system. However, the study is limited by its cross-sectional design and convenience sampling approach. Future research can adopt longitudinal design, larger samples, and additional variables to improve generalizability. So, thank you for your attention. These are the references. Thank you. Hello.
Sir, do you have any questions for the author, or you can?
Hello, am I audible?
Yes. Yeah, yes.
Ma'am, can you tell me have you have collected the data from the users?
Sorry?
Have you have collected data from the users in your study,
Yes,
or
yes,
you have
yes.
used open access database?
Sorry?
Have you used open access database, or
No,
you
no,
have
no, no, no,
collected?
no, no. It is actually primary data, sir. Survey-based data. We have
And how?
actually interviewed the users, and we used a 5-point Likert scale to measure the responses.
Okay, and how many total data you have collected?
Sir, it is more than 300 actually.
Okay,
Uh, the exact number I'm telling you, sir. Just give me 1 minute. As of now, I forgot.
okay, no problem.
Yeah, uh, Sir, 455, sir. The exact
Okay.
data is 455. Actually, I forgot to put it. I should have put it in the presentation. It is there in my
Okay, fine.
paper. So
That's why I have
455.
asked you now, because it was not there in presentation. That's why I
Yeah,
have to
yeah,
ask.
yeah, yeah.
Okay,
Yes,
fine.
sir. I'm so sorry. I forgot to
No
put it.
issues, ma'am. No issues. Okay, fine. We can have the next presentation, please.
Thank
Sure, sir. The next presenter I would like to call is Mamata Kura for the paper title Hybrid UNET with Attention Gates for Lung Nodule Segmentation in Low Dose CT Scans. Are you in the meeting? Okay. We can proceed with the next author. Jonalyn Joy for the paper title Regional Disparities in BMI and WHR using FNRI Big Data Analytics Random Forest Classification with Cloud-Based Processing.
Good morning, sir. Am I audible?
Yes, you're audible. You can start your screen sharing.
Okay, sir. Okay, so good morning, everyone. I'm Jonalyn Joy Labani from Angeles University Foundation, and I'm, excuse me, here to present my research entitled Regional Disparities in BMI and WHR using FNRI Big Data Analytics Random Forest Classification with Cloud-Based Processing. So this study leveraged large-scale nutrition and health datasets from the FNRI, combined with machine learning and cloud computing technologies to identify the regional patterns in nutrition such as across the Philippines. Today, I discuss the motivations behind the study updates and the methodology that I used and the background of the study. Okay. The nutrition health remains a major public health concern worldwide. In a food, in Nutrition Research Institute or FNRI, the key department of the science and technology has been combining malnutrition by releasing comprehensive national data sets enable evidence-based strategies. This study harnessed the FNRIs covering the region, age, gender, ethnicity, weight, BMI, and the social economic support, personalized nutrition, remaining the tailored to the Philippine demographic and geographic context. Despite the ability of the FNRI datasets, the existing Philippines analysis rely primarily on a single decision tree, achieving only 62% accuracy, and the traditional BMI alone, overlooking assembled method, WHR integration, and scalable cloud processing. This create a critical gap in addressing regional disparities with generalized prediction. The recent machine learning, or ML, studies that have demonstrated the value of interpreted and assembled algorithms for obesity and nutrition status that classify the structured health datasets by Gandhi at 2025. When combined with the cloud-based framework such as Apache Spark, these algorithms enables scalable real-time processing of heterogeneous population label data, supporting productive public health interaction between the low-resource environment by Naumal at 2025. Now, the objective of this research is to analyze the regional variation of BMI, WHR, and the using of FNRI database. The development of predictive classification model using the random forest algorithm to identify the most identical functions distribution of BMI and WHR. These demonstrations enables the method and the WHR enhance the prediction accuracy in and balance the real-world demographic datasets and providing geographical insights, absence in international benchmark, and also the offering actionable regional tailored public health recommendation for the resource setting. Now, for the methodology, the empirical study is based on the 2013 FNRI or 8th National Nutrition Survey. The datasets contain 69,505 adults and ages 20 years old over with the completed BMI recorded. Variables include geographic region, age, gender, ethnicity, wealth, social status, and calculated with their height and weight. The patches Spark and also the cloud base was used to distribute process to large-scale data per processing steps and its comprise. The second picture is engineered data cleaning to address the missing value and consistency. Third one is the model development using the random forest classified for the algorithms. And finally, the model evaluation, interpretation, and regional discrepancies. These frameworks allows to transform raw survey data to actionable insights. This is the example of the raw data, which is the 69,000. So this is the datasets attributes by analysis. So I categorized it by region, age, gender, and ethnicity. So why I used random forest? Because the random forest enable to handling large datasets, high demonstrational variables, complex nonlinear relationship, and interactional among predictions. Random forest provides the measure of importance, enabling us to identify which variables contributes most significant to BMI and WHR classification. The cloud-based processing architecture excuse me, cloud-based architecture environment is offer several benefits. Number one is faster computation, scalability, reduced hardware implementation, enhanced collaboration, and reproducibility. By utilizing the cloud resources, we significantly reduce processing time waiting for analytics efficiency and model performance. For the model performance, was evaluated using the standard machine learning metrics such as accuracy, precision, recall, F1 score. These results indicates the random forest effectively classify the BMI and the WHR categories are captured meaningful relationship among predictable variables. So this is the example of predictable category distribution. This bar charts shows in figure the percentage distribution in classes, likely representing the different by health or BMI category. Classes labeled at 00 dominates the prediction accuracy over 80% of the data, and classes 1.0 and 2.0 up to 3.0 are significantly low percentage, indicating the most individuals fall in one predominant category. This imbalance suggested either skewed datasets, model bias toward prediction one class more frequently. So this one is the BMI category. The certain regions existed high proportion for overweight and obesity, while others showed greater. The various data is including economical development, food accessibility, urbanization, lifestyle patterns, and health availability. The BMI categoristic bars shows the breakdown of BMI from obesity, normal, overweight, and underweight. The regional regions in the Philippines, each bar percent BMI category is subdivided into regions such as NCR, Central Luzon, Davao region. The chart highlights how the BMI distribution vary geographically. For the example, a certain region may be higher portions for the obesity or underweight individuals compared to others. The vision is usually identified region distribution of the health outcomes related to the BMI. For the distribution of waist hip ratio, the table shows the presentation distribution categories in relation to the BMI category. The several regions, despite delivered, the WHR level indicate increased risk of cardiovascular metabolic diseases. Some regions with acceptable BMI levels still exhibited unhealth with WHR distribution. This highlights the importance of evaluation. Both BMI and WHR are relying on BMI alone by underestimate health risk for certain population. For the random forest importance analysis identified the several key prediction, including the BMI and the WHR. Among most efficiently variables were age, sex, socioeconomic indicators, geographical region, lifestyle-related factors, contains differently across region. Further analysis to need for localization intervention strategy. For the conclusion, the random forest classified applied in 2013 FNRS nutrition with the 69,500 adults, integrated the WHR identified hidden ratio metabolic with risk of 18 to 20%. Individuals with normal BMI, the model achieved an accuracy of 0.81 with a macro F1 score of 0.67 and accurate of 0.75, confirming that the superior of Sparks process of FNRI data and assembled method for geographically nutrition's profiling. The random forest approach to successfully address of the key limitations single three models, delivering the strong minority class detention while retaining full integrity via features importance. For the recommendation, the target nutrition supplementary by region priorities protein-rich supplements in coastal such as an urban or the NCR communities where obesity prevalence in highest in iron 45 programmers and mountain and rural provinces were underweight. Measurable outcome reduce regional obesity and the nutrition gap with 50% with 3 years taken with the FNR mini survey. The socioeconomic survey inclined to wealth grandit, expand conditional cash for food subsidies for low wealth household. For the gender and the age specific nutrition education, roll out the companies address the undernutrition among females of reproductive age and active programmers from older to adults. For the last one, continue for the FNRI or the DOST, data expansion and symbol modeling with the collaboration of the FNRI to release geotag longitudinal data and immediately pilot random forest and the other assembled such as Grander Bost in existing 2013 to 2021 datasets using the same Spark pipeline and macro F1 evaluation measure to publish benchmark results showing the 0.65 macro. Thank you for your listening. Acknowledge for the FNRI datasets that I've been using and I welcome you to question and answer for my research presentation. Thank you.
Hello, sir. Do you have anything?
Yes, sir. I'm done po.
Hello.
Hello, sir.
Yes, ma'am. Can you throw some light on food habits? I don't think you have considered the food habits of people in this research. I think so.
Okay, sir. By Also, the BMI categories, as you can see, the stock bar breakdowns the BMI categories for normal to underweight, obesity, and overweight by the regions in the Philippines. This is also the difference by region. Like as I mentioned on my conclusion, in NCR, there's wait, already present that difference, the food quality for the urban persons, or
No, no.
for urban.
What I'm asking is about the food habits, like whether they are vegetarian, non-vegetarian, or let's say in India, there is some region where the maximum food consumption is for rice. There are some regions where the maximum food consumption is for wheat. Like that, I'm asking.
Okay, sir.
Uh,
The Philippines don't have like gap for that, sir. As long as they wanted to and they have the money to buy the foods, they can. But as I said, like on urban areas in the Philippines, they don't have enough money to buy, so there things that they categorize for the underweight.
okay, understood. Thank you. Next presentation, please.
Thank you, sir.
Yes. Could you please stop your screen sharing? Thank you. For the next presenter, Ruhi Sethi, for the paper title, The Human Digital Trust Bridge Framework for Mediated Mobile Governance for ICT Adoption in Rural India. Ma'am, do we have you? Okay. We can call the next presenter, Dimo Valev, for the paper title, The Roles of Graphic Design Principles and AI-Driven Design in Advertising Effectiveness.
Hello, good morning, everyone. Can you hear me, please?
Good morning. Yes, I can hear you. You can start your screen sharing.
Thank you. 1 second, please. Can you see my screen, please?
Yes, it's visible, sir. You can start.
All right, thank you. So my name is Dimo Valev. I'm from Middlesex University, Dubai. And my co-author, Sambram Patanayak, is from Amity University, Dubai. I would like to present our research on how graphic design principles and AI-driven design tools influence advertising effectiveness. In the landscape where every brand is racing to adopt artificial intelligence, we wanted to answer a practical and precise question. Does the design logic still matter when AI is doing the producing? And if so, how does it interact with AI to shape the outcomes we actually care about: attention, comprehension, and recall? Now, we're living through simultaneous shifts in advertising. The first one is the attention scarcity. Consumers are exposed to thousands of visual messages every day, and whether an advertisement is noticed often depends entirely on how it is designed. The clarity of the hierarchy, coherence, composition, relevance of the imagery, etc. Budget and targeting alone no longer guarantee visibility as it was before. Second shift is the adoption of AI as the default production tool. Generative systems, layout optimizers, and personalization engines now sit at the center of most large-scale advertising workflows. This changes how design work is done, making visual creation faster, scalable, and automated. What the existing literature has not answered clearly is what happens at the intersection of these two shifts. When design principles and AI tools operate together, what actually drives advertising effectiveness? And this is the gap this study addresses. The central research question is, how do graphic design principles, when combined with AI-driven design tools, influence the effectiveness of advertising. So we pursued three objectives. The first one was to identify how the core design principles, visual hierarchy, color theory, typography, layout, and branding shape attention, comprehension, and recall in contemporary advertising. The second was to examine how AI-driven design tools extend or modify those traditional practices. The third objective is to identify the implications for the industry practice. Now, the study adopted a qualitative and analytical approach combining three complementary methods. First, a structured literature review drawing on academic journals, conference papers, and industry reports to build a conceptual framework covering both graphic design principles and AI-driven advertising tech. Second, case study analysis. We selected 5 global brands, Meta, Nike, Starbucks, Coca-Cola, and Klarna, specifically because each had documented AI adoption in advertising and available performance data. This allowed us to assess effectiveness outcomes, not just adoption patterns. And third, a comparative visual evaluation examining how core design principles were applied, adapted, or overridden within AI-assisted creative workflows across print, display, and social media formats. The combination of conceptual framework, case evidence, and visual analysis gives the study theoretical grounding and real-world practical relevance. Before examining AI, it's important to establish what graphic design principles actually contribute to advertising effectiveness. Our review confirmed that 7 core principles form the structural foundation of effective advertising. Visual hierarchy guides the viewer's attention in deliberate sequence, ensuring the most important information registers first through size, color, contrast, and spatial positioning. Color theory leverages emotional and perceptual cues. Warm hues drive urgency and action. Cooler tones build trust and reliability. AI-assisted color grading is increasingly applying these principles in automated workflows. Typography signals brand personality and ensures messages remain legible and clear. Layout and composition reduces cognitive load through the rule of thirds, white space, grid alignment, etc. Branding consistency builds recognition across channels and touchpoints by maintaining coherent visual language. Imagery communicates brand values as powerfully as the written copy. Authentic, contextually relevant imagery significantly outperforms generic stock visuals on engagement and purchase intent. And of course, interactivity in digital formats. The overarching finding is clear. Advertisements that orchestrate these principles coherently significantly outperform those that apply them inconsistently or not at all. Now, AI-generated graphics have moved from experimental novelty to commercial standard, and the scale of adoption is significant. The Gen AI design market is growing at compound annual growth of 37.5%, projected to reach $1.2 billion in 2026 alone. The broader AI-generated content market, covering media, entertainment, advertising, and digital communication, is expected to reach nearly $54 billion by 2023. For advertisers, that matters because AI enables 3 things that manual production simply cannot match. First is the personalization at scale, producing different ad versions for different segments simultaneously at a cost that makes mass customization economically viable. Second is the rapid variant testing, identifying which layouts, colors, and images perform best in near real time, replacing the long creative cycles with data-driven iterations. And third, dynamic optimization, adjusting creative assets based on live audience behavior, engagement signals, so that the advertising adapts continuously rather than staying static. The question is not whether to use these tools. The adoption's trajectory made that decision for us. The question is whether they're being used in a way that actually improves advertising effectiveness. This brings us to the study's central finding. AI-generated graphics can match and in some cases surpass human-made advertising visuals in measures like click-through rates, visual quality, and recall. Research on generative visual marketing even uses the phrase superhuman effectiveness to describe the performance ceiling that well-guided AI can reach. In controlled comparisons, AI-optimized ads have outperformed human-made alternatives in click-through rates by anywhere from 12 to 50%. But, and this is the critical question, the performance advantage is entirely contingent to the quality of design guidance applied at the input stage. When AI operates within a clear framework of design principles, it amplifies those principles at a scale. The result is advertising that is brand consistent, visually coherent, and emotionally resonant, produced at the speed and volume that manual workflows cannot match. When AI operates without the framework, the output tends to be visually generic, brand inconsistent, less effective than a professionally designed human alternative. The algorithms optimize for engagement signals, but without design logic to direct that optimization. They converge on whatever visual patterns generated clicks last time, which is not the same things as effective advertising. The conclusion is direct. The AI is not the differentiator. The design logic behind the AI is the differentiator. We examined 5 global brands that have integrated AI into the advertising at scale. Meta's Advantage Plus and dynamic creative optimization reduced cost per action by up to 20%, increased conversations by up to 32% by applying machine learning within design templates that maintain visual hierarchy, contrast, and brand consistency. Creative testing time was reduced by 80%. Nike and Starbucks deployed AI-based personalization systems to improve engagement and promotional efficiency, while holding brand guidelines consistent and non-negotiable. Coca-Cola integrated Gen AI across storytelling, customer engagement, and real-time personalization. The AI operated within a tightly defined brand design system, and Klarna achieved measurable reduction in marketing expenditure by deploying AI-generated customer communications, again within established brand and visual standards. This pattern across all 5 cases is identical. The performance gains came not from AI adoption in isolation, but from AI adoption that was aligned with coherent, well-specified design standards. Brands that treated AI as a pure automation tool without investing in the design governance layer produced high volumes of output that was visually inconsistent and less effective.
Excuse
The
me, sir.
findings,
This is just
yes.
a gentle reminder that 10 minutes of the presentation are up.
Do I have another minute, please?
Yeah. You can continue.
So we have the implications for the industry in future practice. The designer's role will shift upstream, which basically means the expertise means encoding creative intent into the AI workflow. Homogenization is a structural risk. And the third one is the design governance is a strategic asset. So the conclusion is that graphic design principles and AI-driven tools are most effective when they operate together, not in isolation. The evidence from literatures, the case analysis, and the comparative visual evaluation all point to the same conclusion. AI extends the reach and speed of good design. It does not replace the design judgment that makes advertising coherent, brand consistent, and emotionally resonant. As the AI systems become more autonomous in their creative decisions, the frameworks that guide those decisions become more, not less, critical to campaign quality. The practical implications for anyone, whether you're a designer, brand manager, researcher, or strategist, is that investing in design logic is not optional when you deploy AI in advertising. It's the condition under which AI actually delivers. And then, of course, here are the future research directions that should explore long-term impact of AI-driven design on brand perception, ethical dimensions of AI-generated advertising, the potential of the immersive technologies such as AR and VR, and of course, development of hybrid creative frameworks that effectively integrate AI automation, and of course, create practical guidelines for this process. Thank you very much for your attention.
Sir, if you have anything, any questions?
Sir, only one thing I would like to ask. What is your opinion whether a human-generated advertisement will perform better or AI-generated advertisement will perform better?
Well, they should, we can't ignore the AI. At this point, we should work together with the AI. That's the conclusion. If you only use AI, then all the adverts sooner or later will become similar or the same, no matter the brand. And you lose the brand personality, and you lose everything that you have built throughout the years. But under human guidance, it will work much better, and it will perform better. It will better looking. It will better designed. Everything will be much better. So we should work together. We as designers, because I'm designer also. We as designers, we should work with the AI, and we cannot be ignored, which is very optimistic for us. We're not going to lose the jobs, right?
Okay, sir. Thank you. We have
Thank
the
you
next
very much.
presentation.
Thank you so much, sir. I would like to call the following authors. Raj Kiran Nair. Is he there? Raj Kiran Nair. Okay. Mamata Kura. Do we have Mamata Kura here? And Ruhi Sethi. Do we have Ruhi Sethi? Okay. I would like to start with the closing remarks. I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the virtual conference. We'll be happy to serve you in the next version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publications will be live within 7 to 8 months. Kindly cooperate with the team of TIBS 2026. I also thank our session chair, Putu Putri Pravitasari, and Dr. Kalpesh sir. Thank you so much. Token of appreciation to the chair on behalf of the team and Global Knowledge Research Foundation. Thank you for your valuable presence. I kindly
Thank you, all of
request
you.
all to switch on the cameras for a quick snapshot of the virtual conference. Yes. Thank you so much, everyone. Stay safe.
Thank you.
Thank you, all of you. Thank you, Tani. Thank you.
Thank you.
Thank you.
Tanish, can I leave?
Yes, sir, you may leave. Thank you so much, sir.
Thank you.
Hello, everyone. Just to introduce the session chair, Putu Putri Pravitasari, who is a lecturer at National Education University, Bali, Indonesia, with expertise in behavioral accounting, auditing, and financial fraud. She is actively involved in teaching, research, and academic development, contributing to the advancement of higher education in Indonesia. We are pleased to have you, ma'am.
Hello, good afternoon, everyone. So can you hear my voice?
Yes, you are audible.
Okay, can we start the session, Chair?
Yeah, ma'am, actually the presentations have been concluded. Like there were 3 presenters who were not present. So the rest of the presenters have been done, ma'am.
Okay, good afternoon, everyone. So before we start the session, I would like to introduce myself first. My name is Putri Prawitasari. I'm from Universitas Pendidikan Nasional. Good morning from the distinguished speakers, researchers, participants, and guests. And it's my pleasure to serve as the session chair for the virtual Room 2D sessions on behalf of the organizing committee. And I would like to warmly welcome you off to the today presentations. And we have a series of interesting research paper covering topics related to AI, machine learning, cybersecurity, and data analytics. And I encourage all of the participants to actively engage the discussion and also take advantage of this opportunity to exchange the knowledge and ideas. And before we begin, I would like to remind everyone to keep their microphones mute during the presentations, and the Q&A sessions will be conducted after each presentations or at the end of the session according to the schedule. Without further ado, let us begin our sessions.
Yes, ma'am. Thank you for your words. The first session of these
Okay.
presentations are over. Yeah. Thank you,
So
ma'am.
the first
Thank you
one,
for-
I would like to start from the presentation from digital investment platforms from the paper presenter Raji Kiran Ernir. Please present your presentation. Who is the first presentations? Please show us your PowerPoints and you can start the presentations.
Ma'am, am I audible to you?
Yes?
Yeah, ma'am, actually, I wanted to tell you that the first session, 2D, with all the presenters have been over. They have concluded their presentations.
So not the first presentations will be presented from
No,
the
no, the
paper.
first, all the presentations in this session have been concluded, ma'am. They have been done.
Okay, thank you so much.
Yeah,
And
yes,
so all of the presentations is done.
yes, ma'am.
Okay, thank you so much for your
Yes,
good
yes.
presentations. And I hope to be all of the presentations will give our contributions. And for all those decisions, I will encourage that all of the sessions will be give us our new educations. And once again, thank you very much for your participations and also contributions. And for all sessions, I wish you all have the productive contributions and also the conference and pleasant day ahead. Thank you so much, guys, for your time.
Thank you so much, ma'am. Thank you.
Thank you.